Hello, and welcome to Boring Science to Sleep, a quiet place where science becomes slow, soft, and easy to drift through. Tonight, we're going to gently explore quantum fields, not to learn everything, not to master complicated theories, but simply to notice them slowly, calmly, and from a comfortable distance. If you truly enjoy these calm journeys through the hidden layers of reality, you're welcome to like this video and subscribe, only if it feels right for you. And when you're ready, let me know in the comments where you're listening from and what time it is right now. It's always a quiet joy to see how many places and moments gather here together beneath the same night sky. Now, dim the lights. Maybe let a fan hum softly in the background. Settle into your favorite sleeping position and allow your breathing to become a little slower. There is nowhere you need to go, nothing you need to solve, nothing you need to remember. For the next little while, you can simply listen and drift. You are safe, you are comfortable, and together, we are going to wander through one of the deepest questions science has ever asked. What is the universe really made of? Not the stars, not the planets, not the oceans or mountains, but the layer beneath all of those things, the quiet foundation from which everything seems to emerge. And as we begin, you don't need to hold on to every idea. You don't need to follow every detail. The science can simply drift around you like a gentle current. Just listen and rest. Tonight, we begin at the beginning, with a question so familiar that most of us rarely stop to ask it. What is a thing? When you look around your room, everything appears solid and certain. Perhaps there is a blanket resting across you, a pillow supporting your head, a wall nearby, a ceiling above. Objects, simple objects, things that seem complete and separate. And for most of human history, that is exactly how reality appeared. The world felt like a collection of things. A stone was a thing. A tree was a thing. A cloud was a thing. A person was a thing. Even the stars seemed like distant objects hanging in the darkness. If you could travel back thousands of years and ask someone what the universe was made of, they might imagine tiny pieces fitting together like grains of sand on a beach. And in many ways, that idea feels natural. After all, when you break something apart, you often discover smaller pieces. A branch becomes splinters, a rock becomes pebbles, a loaf becomes crumbs. The mind naturally wonders whether everything can be divided again and again until the smallest possible pieces are found. For a very long time, people imagined that these tiny pieces were the true building blocks of reality. Little ingredients hidden beneath everything. Tiny objects too small to see. And as the centuries passed, science appeared to confirm this intuition. Atoms were discovered, then smaller components inside atoms, then even smaller structures beneath those. Each discovery seemed to whisper the same reassuring message. Keep looking, keep dividing. Soon you will find the smallest things, the final pieces, the ultimate building blocks. And for a while, this seemed reasonable. The universe looked like a magnificent construction made from unimaginably tiny parts. But something curious began to happen. The deeper scientists looked, the stranger the universe became. Imagine standing on the shore of a calm lake at dusk. The surface appears smooth and predictable. Yet as you look closer, small ripples appear, then subtle currents beneath them, then reflections that blur the boundary between water and sky. The closer you examine the scene, the less simple it becomes. Reality behaved in much the same way. Scientists developed instruments capable of exploring scales far smaller than anything human eyes could perceive. They expected tiny objects, tiny particles, tiny building blocks. Instead, they encountered behavior that seemed almost dreamlike. Sometimes light behaved like a wave spreading through space. Sometimes it behaved like a tiny arrival, appearing at a single point. Electrons behaved in similarly puzzling ways. At moments they seemed spread out like ripples across a pond. At other moments, they appeared as if they were concentrated into tiny, localized events. The old picture began to wobble, not because it was completely wrong, but because it was incomplete. The universe seemed to be hinting at something deeper, something hidden beneath the idea of particles, something more continuous, more subtle, more difficult to picture. Imagine listening to a distant piece of music through a wall. At first, you hear only individual notes, separate sounds, distinct events. But as you listen longer, you begin to notice something beneath the notes, a flowing melody connecting them, a pattern that exists before any individual sound appears. The notes are real, but they are not the whole story. Perhaps particles are similar. Perhaps what we call particles are not the deepest layer of reality. Perhaps they are more like notes, emerging from something larger, something continuous, something present everywhere. This possibility changed the direction of modern physics. Slowly, carefully, over many decades, scientists began replacing the image of a universe built from tiny objects with something far stranger. A universe built from fields, not fields of grass beneath an open sky, not farms or meadows, but invisible conditions stretching throughout space itself, structures that exist everywhere, even where nothing seems to exist at all. And if that sounds mysterious, that's perfectly fine. There is no need to understand it all tonight. For now, simply allow the idea to settle softly in the background. The possibility that beneath every object, every atom, every star, every breath you take, there may exist something deeper than particles. Something quieter, something continuous, something woven gently through all of existence. And in a little while, we may begin to explore what those invisible fields actually are. For a long time, the idea seemed wonderfully simple. The universe appeared to be built from tiny things, tiny pieces, tiny building blocks, tiny objects moving through space. And if you had lived 100 years ago, you might have felt quite confident in that picture. After all, it matched everyday experience. A ball travels through the air, a raindrop falls from a cloud, a pebble rolls down a hill. Objects move from one place to another. The world feels predictable in this way, comfortably solid, comfortably understandable. And so, when scientists first began exploring the smallest scales of nature, they naturally expected the same rules to apply. They imagined tiny particles behaving like miniature versions of ordinary objects, little grains of reality, tiny marbles drifting through an invisible emptiness. But nature had a surprise waiting. A very quiet surprise, one that would slowly transform our understanding of reality itself. Imagine standing beside a calm pond on a still evening. The water is smooth and dark beneath the fading light. You pick up a small stone and gently toss it into the center. Immediately, ripples begin spreading outward. Circular waves glide across the surface. They overlap. They interfere. They combine and separate. This behavior feels familiar. Water waves have always behaved this way. Now imagine something very different. Imagine throwing a handful of tiny beads across the pond. The beads would not spread into waves. Each bead would travel along its own path. Each one would arrive independently. The two behaviors feel completely different. One belongs to waves, the other belongs to objects. For centuries, this distinction seemed perfectly clear. Then scientists began studying light more carefully, and suddenly, the distinction began to blur. Experiments revealed that light could spread and overlap much like the ripples on a pond. When light passed through narrow openings, it produced beautiful patterns of bright and dark regions, patterns that looked remarkably similar to overlapping water waves. The evidence seemed clear. Light behaved like a wave. Yet there was a problem. When scientists tried to measure light arriving at a detector, it did not appear as a smooth, spread-out wave. Instead, it arrived in tiny individual events, tiny arrivals, tiny deposits of energy, almost as though invisible particles had struck the detector one by one. The universe seemed unable to make up its mind. Was light a wave, or was it a particle? Neither answer seemed completely satisfactory. And then things became even stranger. Because light was not alone, electrons began behaving in the same puzzling way. Electrons had long been considered particles, tiny objects carrying electric charge, tiny pieces of matter. Yet when scientists guided electrons through carefully designed experiments, they displayed behaviors that looked astonishingly wave-like. Imagine a narrow wall with two small openings. A simple arrangement, nothing dramatic. If tiny marbles were thrown toward the wall, some would pass through the left opening and some through the right. Eventually, a simple pattern would form behind the wall, exactly what common sense predicts. But electrons refuse to cooperate with common sense. Instead of forming the pattern expected from tiny objects, they created a delicate arrangement resembling overlapping ripples, a wave pattern, and perhaps most remarkably, the pattern appeared even when electrons were sent through one at a time. Slowly, patiently, one electron, then another, then another. Each arrival seemed tiny and localized. Yet together, they gradually built the same wave-like pattern. It was as though every electron somehow behaved like a broad ripple moving through space and a tiny arrival occurring at a single location. The contradiction felt impossible. Scientists found themselves staring at results that challenged centuries of intuition. Imagine hearing a distant melody drifting through the night. You recognize it as music because the notes blend together into a continuous pattern. Now imagine the melody arriving one note at a time, from completely different directions, while somehow still forming a coherent song. The experience would feel confusing, beautiful perhaps, but deeply puzzling. This was how the quantum world appeared. The old picture of tiny particles moving along simple paths began to crack. Not suddenly, not dramatically, but steadily. Experiment after experiment revealed behaviors that ordinary objects simply could not explain. Sometimes electrons seemed spread across possibilities. Sometimes they appeared concentrated into specific outcomes. Sometimes light behaved like a traveling ripple. Sometimes it behaved like a tiny arrival. The deeper scientists looked, the less comfortable the old model became. It was as though reality itself was gently whispering that something important had been overlooked. Not a small detail, not a minor correction, something fundamental. Imagine walking through a dense morning fog. At first, nearby objects appear distinct: a tree, a fence, a pathway. But as the fog thickens, the sharp boundaries begin to soften. Separate objects seem connected by a larger atmosphere surrounding them all. The distinction between individual things becomes less obvious. Something similar was happening in physics. Scientists began wondering whether particles were not truly independent objects at all. Perhaps they were expressions of something larger, something continuous, something that filled space itself, a deeper layer beneath the particles, a hidden foundation. The old picture had imagined reality as a collection of tiny beads. But what if the beads were only temporary appearances? What if they emerged from something more fundamental? Something capable of producing both wave-like behavior and particle-like arrivals? This question lingered quietly. It followed physicists through laboratories, calculations, and long evenings of thought. And little by little, an entirely new picture began to emerge. A picture in which particles were no longer the starting point. A picture in which something else came first. Something present everywhere. Something that existed even in the emptiest regions of space. Something known as a field. And as we continue our slow journey, we may begin to discover why fields offered a solution to a mystery that particles alone could never fully explain. Now that the familiar picture of tiny particles has begun to soften around the edges, we can slowly turn toward a new idea, an idea that may sound unfamiliar at first, an idea that quietly sits beneath much of modern physics, the idea of a field. When you hear the word field, you might imagine a wide meadow beneath an open sky, a peaceful landscape, tall grass moving gently in the wind. But in science, the word field means something different, something more subtle, something almost invisible. And before we approach the deeper quantum fields that fill the universe, it helps to begin with examples that already surround you every day. Examples so ordinary that they often go unnoticed. Imagine that you are resting comfortably inside a quiet room on a cool evening. The room feels warm, comfortable, safe. But if you could somehow measure the temperature in every corner of the room, you would discover something interesting. The temperature would not be exactly identical everywhere. Near a window, the air might be slightly cooler. Near a lamp, perhaps slightly warmer. In another corner, almost the same, but not quite. Every location would have its own value, a tiny description of how warm or cool that particular place happens to be. If you could draw all those values across the room, you would create something called a temperature field. Not an object, not a substance, simply a value existing at every location, a quiet pattern spread through space. Now imagine stepping outside. A gentle breeze brushes across your skin. You notice the air moving softly around you. Yet the wind is not exactly the same everywhere. A few steps away, it may move a little faster. Near a tree, it may swirl in a different direction. Across an open field, it may become smoother and steadier. Every point in space contains its own description of how the air is moving. Together, these descriptions form a wind field. Again, not an object, not a collection of tiny things, but a pattern spread throughout a region, a condition existing everywhere at once. Or perhaps imagine climbing a mountain. As you rise higher, the air gradually becomes thinner, the pressure changes, the atmosphere feels different. Every location has its own value, its own description, and together those values form another field, a pressure field. The more examples you encounter, the more natural the idea becomes. A field is simply a way of describing something that exists throughout space, something that assigns a value to every location. And once this idea settles gently into your mind, a deeper possibility begins to appear. What if some of the most fundamental features of reality are also fields? Not temperature, not wind, not air pressure, but something deeper. Something woven directly into the structure of existence itself. Imagine walking through a dark room with your hand gently extended in front of you. You cannot see the air, you cannot hold it, yet you can feel subtle differences. A slight warmth near one wall, a faint coolness near another, perhaps the soft movement of air from a nearby vent. You are sensing invisible conditions that already fill the room. In a similar way, modern physics suggests that space itself contains invisible conditions. Not emptiness, not nothingness, but subtle structures that exist everywhere, quietly, continuously, whether we notice them or not. This requires a small shift in perspective. For most of our lives, we learn to think in terms of objects, tables, chairs, trees, clouds, planets, people. The world seems built from separate things. Fields invite us to think differently. Instead of imagining reality as a collection of isolated objects, we begin imagining it as a collection of invisible patterns, continuous landscapes, gentle layers spread throughout space. You might picture a sunset. At first glance, it appears filled with colors: orange, gold, pink, purple. Yet if you look carefully, there are no sharp boundaries between those colors. One shade slowly becomes another. The entire sky behaves as a continuous gradient. Fields are somewhat like that. Not solid pieces, not isolated points, but continuous patterns stretching across a larger whole. This is one of the reasons many physicists eventually became fascinated by fields. They seemed capable of explaining behaviors that particles alone struggled to describe. Because once a field exists everywhere, something remarkable becomes possible. The field can change. It can respond. It can carry disturbances. It can ripple. And if you remember the strange experiments from our previous journey, those ripples begin to sound surprisingly familiar. The wave-like behavior of light, the wave-like behavior of electrons, the spreading patterns that once seemed so mysterious. Perhaps those behaviors were not strange at all. Perhaps they were exactly what we should expect if reality contains fields. Imagine a calm lake beneath moonlight. The surface is smooth, still, peaceful. Then a single drop touches the water. Immediately, ripples begin spreading outward. The water itself does not travel across the lake. Instead, the disturbance moves, the pattern moves, the information moves. A field behaves in a surprisingly similar way. When something disturbs a field, the disturbance can travel through it, not because little objects are carrying the disturbance from place to place, but because the field itself allows patterns to move across its continuous structure. This idea will become increasingly important as our journey continues. Because the universe may not be built from particles first. It may be built from fields first. And what we call particles may emerge later as special patterns within those fields. For now, though, there is no need to rush ahead. Simply allow the idea to rest gently in your thoughts. The possibility that space is not empty. The possibility that invisible structures surround you even now. The possibility that beneath every object you have ever seen lies a deeper landscape. Not made of tiny solid pieces, but of quiet patterns spread throughout existence. And in a little while, we may begin to explore what happens when those invisible fields start to move. Now that the idea of a field has begun to settle gently into your mind, we can take one small step further. Not a hurried step, not a difficult step, just a quiet shift in perspective. A little while ago, we explored familiar fields, temperature spreading through a room, wind moving across a landscape, pressure changing through the atmosphere. These examples helped us understand what a field is, a value existing throughout space, a condition present at every location. But those examples all depend on something else. Temperature depends on matter, wind depends on air, pressure depends on an atmosphere. If all the air disappeared, those fields would disappear as well. And this raises a fascinating question. What about the deeper fields of nature? The fields that physics believes are woven into reality itself? Do they also disappear when matter disappears? Or do they remain? Imagine drifting far away from Earth, far beyond cities and oceans, beyond clouds, beyond the atmosphere, past the moon, past the planets, past even the distant edge of the solar system. Eventually, you arrive in a vast region of darkness between the stars, a place that appears almost completely empty. No trees, no mountains, no oceans, no air, no weather, only silence. At first glance, it might seem as though there is nothing there at all, a perfect emptiness, a blank canvas. Yet according to modern physics, even here, space is not truly empty. Something remains, invisible, silent, continuous. Fields. Something road contains fewer cars than a crowded road. So when we imagine empty space, we naturally imagine the absence of all things. But the universe appears to be more subtle than that. Even where matter becomes scarce, fields remain, quietly stretching through the darkness. Imagine standing outside, beneath a clear night sky. You cannot see the air around you. yet it surrounds you completely. You move through it effortlessly. You rarely think about it, and still, it is always there. The fundamental fields of nature are similar in a way, not because they are made of air, not because they are substances floating through space, but because they form part of the background of reality itself. You do not see them directly, yet they remain present, everywhere. One of the simplest examples is gravity. You have lived with gravity every day of your life. You rarely stop to notice it. Yet every step you take is guided by it. Every falling leaf, every drifting raindrop, every ocean tide. Gravity quietly shapes their motion. Imagine tossing a small pebble into the air. The pebble rises, slows, pauses, then returns to Earth. It does not need to touch the ground to feel gravity. The influence is already present throughout the surrounding space. The pebble simply responds to a condition that exists everywhere nearby. For many years, scientists described this as a gravitational field, a way of describing how the influence of mass extends through space. A quiet pattern surrounding planets, stars, and galaxies. A gentle guidance system shaping motion. And while modern physics now describes gravity in even deeper ways, the image of a field remains a useful and intuitive one. It reminds us that space is not merely an empty stage where events occur. Space possesses structure, character, organization. Another field surrounds you at this very moment, the electromagnetic field. Unlike gravity, this field plays a role in an astonishing number of everyday experiences. The light reaching your eyes, the warmth of sunlight, the signal received by a phone, the information carried through a wireless network, the operation of radios, screens, and countless technologies, all depend upon the electromagnetic field, and yet you cannot see the field itself. You only observe its effects. The field is like an invisible landscape, a hidden layer beneath familiar experiences. Imagine entering a vast valley before sunrise. The land is still hidden in darkness. You cannot clearly see the hills and contours around you. Yet as you walk, you gradually notice their influence. The slope beneath your feet, the direction water flows, the shape of the horizon. The landscape reveals itself indirectly through its effects. Fields often reveal themselves in a similar way. We rarely observe them directly. Instead, we observe how things respond to them. Light travels, objects fall, signals move, particles interact, and through these responses, the hidden landscape becomes visible. As physics continued to develop, scientists discovered something remarkable. The universe does not appear to contain only one or two fields. It appears to contain many, each associated with different aspects of nature, different patterns, different behaviors, different possibilities. Some fields are connected to matter. Some are connected to forces. Some influence how particles move. Others influence how particles acquire their properties. Together they form an intricate network filling the cosmos. Not isolated pieces, not disconnected objects, but overlapping layers woven throughout the same space. Imagine listening to an orchestra, preparing before a performance. The room is filled with many instruments, violins, cellos, flutes, horns, each capable of producing its own unique sound. Yet all share the same concert hall. Their music overlaps within the same space. The fields of nature are somewhat similar. Many fields, one universe, many possibilities, one underlying reality. And perhaps the most surprising idea of all is this. These fields do not merely occupy space. They may be more fundamental than the particles we originally believed were the building blocks of reality. The fields come first. The particles may come later, as special patterns, special vibrations, special disturbances moving through those fields. But that part of the story is still waiting for us. For now, simply rest with the image. A universe that is not empty. A universe quietly filled with invisible structures. A universe woven from fields, stretching across every star, every planet, every atom, and every silent region between galaxies. And in a little while, we may begin to discover what happens when those invisible fields are gently stirred into motion. By now, the universe may be beginning to feel a little different. Not because the stars have changed, not because the planets have changed, not because your room has changed, but because the picture in your mind is slowly changing. A little while ago, reality may have seemed like a collection of separate objects, tiny pieces assembled into larger pieces, particles building atoms, atoms building matter, matter building worlds. But now another possibility has appeared, the possibility that beneath all those familiar objects lie fields, invisible structures filling space, quietly present everywhere. And once you begin imagining fields as real, a new question naturally follows. What happens when a field changes? What happens when it moves? What happens when it is disturbed? To explore this, it helps to return to something familiar. Imagine a perfectly calm lake beneath the night sky. The water is smooth, still, reflective. The stars above appear almost motionless on its surface. For a moment, everything feels peaceful. Then a single drop of water touches the lake. Nothing dramatic, just one tiny disturbance. Yet immediately, something begins to happen. Circular ripples spread outward. The disturbance travels. The pattern expands. The influence moves across the surface. And perhaps the most interesting part is this. The water itself does not travel all the way across the lake. Instead, the disturbance travels. The pattern travels. The information travels. One small motion gives rise to a much larger movement. This simple image turns out to be surprisingly useful, because fields behave in much the same way. When a field is disturbed, the disturbance does not necessarily stay where it began. Instead, it can spread outward. It can travel. It can ripple through space. And suddenly, many of the strange behaviors that puzzled scientists begin to feel much more natural. Imagine gently plucking a guitar string. The moment your finger releases it, the string begins to vibrate. Not just at the place where you touched it, the entire string participates. A wave moves along its length. Energy spreads through the instrument. A soft note fills the room. The sound feels effortless, natural, expected. You would never be surprised that a vibration creates a wave. That is simply what strings do. And perhaps, scientists eventually realized, that is simply what fields do as well. When fields are disturbed, they naturally produce waves. They naturally create ripples. They naturally allow patterns to travel through space. This realization solved part of a mystery that had troubled physics for many years. Remember the strange behavior of light. The way it spread out. The way it interfered with itself. The way it formed wave-like patterns. Those behaviors seemed mysterious when light was imagined as a tiny object. But once light became associated with a field, the mystery softened. Of course it could behave like a wave. It was moving through a field, and fields naturally support waves. The same idea helped explain electrons. Electrons had once been imagined as tiny little beads, tiny objects racing through space. But the experiments suggested something different. Sometimes electrons spread out. Sometimes they formed interference patterns. Sometimes they behaved exactly the way waves behave. And perhaps that should not have been surprising. If electrons were connected to a field, then wave-like behavior was no longer strange. It was expected. Imagine once more that moonlit lake. Now picture two small pebbles dropping into the water at different locations. Ripples spread outward from each disturbance. Eventually the ripples meet. Where they overlap, something beautiful happens. Some waves reinforce one another. Some cancel one another. The surface develops an intricate pattern of peaks and valleys. This phenomenon is called interference. But you do not need to remember the word, only the image. Waves meeting waves, patterns combining with patterns. The important thing is that this behavior emerges naturally from waves. No special tricks are required, no mystery is needed. It is simply how ripples behave, and scientists discovered the same behavior appearing again and again in the quantum world. Light produced interference. Electrons produced interference. Other particles produced interference. The evidence seemed to point toward a remarkable conclusion. At a deep level, nature behaves less like a collection of tiny objects and more like a collection of fields capable of supporting waves. The universe began to resemble an enormous ocean of invisible structures. Not an ocean made of water, an ocean made of fields. And throughout this invisible ocean, countless disturbances travel continuously. Some large, some small, some lasting only a brief moment, others persisting for extraordinary lengths of time. Imagine standing on a quiet shoreline. Far away, gentle waves roll across the water. Some arrive softly at the beach. Others fade before reaching you. Some combine into larger patterns. Others disappear into stillness. The surface is never completely motionless. There is always some subtle movement, some quiet rhythm. Fields appear to behave in a similar way. Space itself may be filled with an ongoing dance of ripples and vibrations. Most remain invisible to us. Most pass unnoticed. Yet they form the hidden activity beneath the world we experience every day. And perhaps there is something comforting about this image. The universe not as a machine built from rigid parts, not as a collection of isolated objects, but as a living landscape of patterns, a continuous tapestry of gentle motions, a place where disturbances travel gracefully through invisible structures, a place where everything remains connected through the fields that fill space. Yet there is still a puzzle waiting for us, because if fields create waves, and waves spread out across space, why do our measurements so often reveal tiny localized events? Why does a broad ripple sometimes appear as a single arrival? Why does a wave sometimes seem to become a particle? That question lingered in the minds of physicists for many years. And in a little while, we may begin to explore how waves leave their mark upon the world, one tiny event at a time. As you settle a little deeper into this journey, you may notice that the universe is beginning to feel less like a collection of objects and more like a landscape of invisible motion, fields stretching through space, ripples moving through those fields, gentle disturbances traveling across an unseen ocean. In many ways, this picture feels surprisingly natural. After all, waves are familiar. You have seen them on water. You have heard them in sound. You have watched them move through grass on a windy day. Waves spread. Waves overlap. Waves travel. Nothing about that feels especially mysterious. And yet, there remains one puzzle. A puzzle that troubled scientists for decades. If reality contains waves moving through fields, then why do experiments so often reveal something that looks like a particle? Why do broad, spread-out waves leave such tiny, localized marks? To understand this, imagine yourself once again standing beside a quiet lake. The surface is calm, moonlight dances gently across the water. Far from the shore, a ripple begins to spread outward. The ripple grows wider and wider as it travels. Its influence reaches across a large area. Now imagine that near the shoreline, a single floating leaf rests on the water. The ripple eventually reaches it. For a brief moment, the leaf moves. A tiny event occurs, a small interaction. The ripple may have occupied a large region of the lake, but the effect you notice happens in one specific place. The leaf moves. The interaction is local. This simple image contains an important clue. In the quantum world, waves often spread across space, but interactions happen at particular locations. And it is those interactions that our instruments detect. Imagine walking through a dark field at night, carrying a lantern. The beam of light illuminates only a small patch of ground at any given moment. The landscape may extend far beyond what you can see, but your attention is drawn to the places where the light falls. Measurements work in a somewhat similar way. They do not reveal the entire field all at once. They reveal where an interaction occurs, where energy is transferred, where a ripple leaves its mark. This was one of the great insights that helped scientists understand the strange behavior of light and matter. The wave spreads. The interaction appears. The two are not competing explanations. They are different parts of the same process. Imagine hearing distant thunder rolling across a valley. The sound spreads broadly through the air. It fills a large region. Yet if that sound causes a single window to rattle, your attention is drawn to the window. The wave was widespread. The effect was localized. Something similar happens in the quantum world. The field disturbance may occupy a broad region, but when energy is delivered, it arrives in a specific interaction, a specific event, a specific place. This is why experiments often reveal what looks like a particle, not because the wave suddenly transforms into a tiny marble, not because the field abandons its wave-like nature, but because the interaction itself occurs locally. The instrument records the moment energy arrives. It records the mark left behind. Imagine a gentle rain falling across a large field. The cloud above spreads over a wide area. The rain exists throughout the sky. Yet when a single drop lands on your hand, your attention focuses on that tiny point of contact. You do not experience the entire cloud at once. You experience one arrival, one interaction, one small event. The cloud remains broad. The experience becomes local. This way of thinking helped soften one of the most confusing aspects of quantum physics. For many years, people argued about whether light was truly a wave or truly a particle. But perhaps that question was never quite right. Perhaps it was like asking whether a song is a vibration or a sound. The answer depends on which part of the process you are describing. The vibration creates the sound. The sound reaches the listener. Both belong to the same reality. Similarly, the field creates the wave. The interaction creates the localized event. Both belong to the same process. Neither needs to replace the other, and there is another subtle idea hidden here. The energy carried by a field is not transferred in arbitrary amounts. Nature appears to prefer discrete deliveries, small packets, specific amounts. Imagine climbing across a stream using stepping stones. You cannot place your foot anywhere you wish in the water. Instead, you move from one stable stone to the next, one step, then another, then another. Nature often behaves in a surprisingly similar way. The energy carried by a field tends to arrive in distinct packets rather than an endless continuum. These packets are what physicists call quanta, but you do not need to remember the word. Simply imagine small, organized deliveries of energy. Not an uninterrupted blur, not an infinite range of possibilities, but specific amounts arriving through specific interactions. This is why light can spread like a wave across space and still arrive as tiny individual events. The wave belongs to the journey. The packet of energy belongs to the arrival. The broad ripple belongs to the field. The tiny mark belongs to the interaction. And once these ideas settle together, the old contradiction begins to soften. The universe no longer seems to be switching back and forth between two different identities. Instead, it appears to be expressing two aspects of the same deeper reality. A reality built from fields. A reality filled with waves. A reality where interactions leave delicate marks that we interpret as particles. And as scientists explored this picture more deeply, they discovered something even more surprising. The vibrations allowed within these fields were not completely free. They followed certain preferred patterns, certain stable arrangements, almost as though the universe itself favored particular notes within an invisible cosmic melody. And in a little while, we may begin to listen to that hidden music and discover why nature seems to prefer some vibrations over others. As you continue drifting through this quiet landscape of fields and waves, you may begin to notice a gentle pattern emerging. The universe no longer feels like a collection of tiny objects bouncing through empty space. Instead, it feels more like an immense ocean of invisible fields. Fields that can ripple, fields that can vibrate, fields that can carry patterns from one place to another. And yet, there is something curious about these vibrations. something surprisingly orderly, because nature does not seem to allow every possible vibration, not every pattern, not every motion, not every arrangement. Instead, nature appears to favor certain patterns over others, certain stable forms, certain preferred vibrations. And to understand this, it helps to begin with music. Imagine sitting quietly in a dimly lit room. Somewhere nearby, a guitar rests against a chair. The room is peaceful, still, almost silent. Then someone gently plucks one of the strings. A note fills the air, soft, clear, steady. The sound feels natural, almost effortless. But something remarkable is happening. The string is not vibrating in a completely random way. It is not choosing any motion it wishes. Instead, the string naturally settles into specific patterns of vibration, patterns allowed by its length, its tension, its physical structure. Certain notes emerge easily, certain patterns remain stable, others simply do not occur. Imagine trying to force the string into a shape that cannot sustain itself. The pattern quickly disappears. The string returns to one of its preferred modes, one of its natural rhythms, one of its allowed notes. This simple idea turns out to be surprisingly important, because fields behave in a similar way. When fields vibrate, they do not vibrate in completely arbitrary ways. Certain patterns are stable, certain vibrations endure, certain arrangements naturally emerge. Nature seems to prefer particular notes within its invisible symphony. Imagine standing beside a calm pond once again. A familiar image by now. Moonlight rests softly on the surface. You gently touch the water. Small ripples spread outward. Most fade quickly. But imagine a different situation. Imagine a perfectly shaped basin, where certain wave patterns reinforce themselves. The ripples settle into beautiful standing arrangements, stable forms, persistent shapes, patterns that remain long after a random disturbance would have disappeared. Fields often behave in a similar manner. They possess preferred patterns, stable vibrations, enduring rhythms, and these special vibrations play an extraordinary role in the story of reality. For a long time, scientists struggled to understand why energy seemed to arrive in distinct amounts rather than as an endless continuum, why nature seemed to prefer specific packets, specific deliveries, specific increments. The answer gradually emerged through the behavior of waves, because when only certain vibrations are allowed, only certain amounts of energy naturally appear. Imagine climbing a staircase in the dark. You move from one step to the next. You cannot stand halfway between two solid steps. The structure itself guides your movement. The staircase quietly limits the possibilities. Nature often behaves in a similar way, not because reality contains literal stairs, but because fields possess preferred modes of vibration, preferred patterns, preferred states, and as a result, energy often appears in organized packets rather than in arbitrary amounts. This idea became one of the foundations of modern physics. Yet tonight, there is no need to dwell on technical language, no need to memorize terminology. Instead, simply hold on to the image, a universe that resembles music. Not music that someone composed, not music performed in a concert hall, but a deeper kind of music, a universe in which invisible fields support stable notes, stable patterns, stable vibrations. Imagine walking through a great cathedral long after everyone has gone home. The building is empty. The air is still. You softly sing a single note. The sound spreads through the vast space. Certain tones linger. Certain frequencies resonate. The architecture itself encourages some patterns while discouraging others. The structure quietly shapes the sound. Fields appear to do something similar. Their structure influences which vibrations persist, which patterns remain stable, which arrangements become part of the physical world. And this brings us closer to understanding what particles truly are. Earlier, we explored the idea that particles may not be fundamental objects. They may instead be localized manifestations of field activity, special disturbances, special vibrations. Now we can refine that picture a little further. Particles are not just any vibrations. They are stable vibrations, preferred vibrations, allowed vibrations, much like the clear note produced by a guitar string rather than a random burst of noise. Imagine listening to an orchestra warming up before a performance. At first, the sounds seem scattered. Individual notes drift through the room. Fragments of melodies appear and disappear. Then gradually, harmony emerges. Patterns begin to organize themselves. The music becomes coherent, structured, recognizable. The universe appears to contain a similar preference for order, a preference for stable patterns over chaos, a preference for enduring arrangements over fleeting disturbances. And from these stable arrangements, the familiar world begins to emerge. Matter, light, atoms, stars, planets, even life itself, all arising from patterns that nature allows, patterns that endure, patterns woven into the behavior of fields. The deeper physicists looked, the more they discovered that reality was not built from random vibrations. It was built from preferred vibrations, allowed notes within an invisible cosmic instrument. And among those notes, one family of vibrations would prove especially important, because some of them travel across the universe, carrying light itself. They illuminate stars, warm planets, fill the night sky, and quietly make vision possible. And in a little while, we may begin to explore the field whose vibrations become light and discover how the universe learned to shine. As you continue drifting through this quiet exploration of reality, you may remember the image we encountered a little while ago, a universe filled with invisible fields, not empty space, not nothingness, but a vast landscape of hidden structures stretching across the cosmos. And among all those fields, one is especially familiar to you, even if you have never seen it directly, because every morning it helps bring daylight to your eyes. Every evening, it helps carry the glow of distant stars across the darkness. Every moment, it quietly allows you to see the world around you. This is the electromagnetic field. The name may sound technical at first, but tonight, there is no need to think of it as a complicated scientific term. Instead, imagine it as one of the great invisible oceans of the universe, a field extending throughout space, a field capable of carrying vibrations, a field capable of carrying light itself. Imagine stepping outside on a clear morning. The sun has just risen above the horizon. Golden light spreads gently across rooftops, trees, and distant hills. The warmth feels comforting. The world slowly awakens. Birds begin to sing. Shadows stretch softly across the ground. Everything appears calm and familiar. Yet something extraordinary is happening. Tiny vibrations have traveled across an enormous distance. They began their journey deep within the sun. They crossed millions of miles of space, and eventually they arrived here, reaching your eyes. The light feels immediate, effortless, almost ordinary, yet it is one of the most remarkable processes in the universe. For centuries, people wondered what light actually was. Was it a stream of particles, a wave, a substance, a mysterious force? The answers changed over time. But modern physics eventually arrived at a beautiful idea. Light is a vibration of the electromagnetic field. Just as ripples move across the surface of a pond, light can be understood as a ripple moving through this invisible field. The field itself remains everywhere. The ripple travels through it, and suddenly, many familiar experiences begin to feel connected. Sunlight, moonlight, the glow of a candle, the beam of a flashlight, the colors of a sunset. All are expressions of the same underlying field. Different vibrations, different patterns, different notes within the same invisible instrument. Imagine a vast piano stretching across the universe. Not a piano made of wood and strings, but a metaphorical one, a cosmic instrument capable of producing countless notes. Some notes are deep and slow, others are quick and energetic. Each vibration carries its own character, its own personality. its own way of interacting with the world. Light behaves in a surprisingly similar way. Some vibrations are slower, some are faster, and these differences help determine how we experience them. The colors you see around you emerge from different patterns of vibration within the electromagnetic field. The deep red glow of a sunset, the soft blue of a clear afternoon sky, the gentle green of leaves moving in the breeze, all are connected to different rhythms within the same field, different notes within the same cosmic melody. Imagine listening to an orchestra. The same violin can produce many notes. The same instrument can create entirely different moods. A quiet lullaby, a joyful dance, a thoughtful melody. The instrument remains the same, only the pattern changes. The electromagnetic field behaves in a similar way. The field remains, the vibrations change, and from those changes emerge the rich variety of light that fills our experience. But light is not the only thing carried by this field. The electromagnetic field participates in many aspects of modern life. In fact, it quietly surrounds you even now. Imagine a radio station broadcasting music across a city. The signal travels invisibly through space. No wires connect the station to every listener. No physical path is visible. Yet the information arrives. The field carries the pattern. Or imagine a message traveling to a phone. Again, invisible signals move through the surrounding environment. The field quietly transports information from one place to another. The same field that carries sunlight from the sun also helps carry music, voices, images, and data across the modern world. Even the screen displaying a video or illuminating a room relies upon carefully controlled interactions within the electromagnetic field. What appears ordinary is beneath the surface, deeply connected to this invisible structure. And perhaps that is one of the most beautiful aspects of science. The extraordinary often hides inside the familiar. The miraculous hides inside the everyday. A beam of sunlight crossing a window, a glowing screen in a quiet room, a distant star shining through the darkness, all become expressions of the same underlying reality, the same field, the same invisible ocean, the same cosmic landscape. As physicists explored the electromagnetic field more deeply, they discovered something else as well. The vibrations of this field can arrive in those organized packets of energy we discussed earlier. Stable, allowed vibrations, distinct arrivals. These packets became known as photons. But tonight, there is no need to focus heavily on the name. Simply imagine them as tiny arrivals of light, small deliveries of energy, localized moments where a broader ripple leaves its mark. The wave travels, the arrival occurs, the field remains. Together, these ideas form a picture that is both elegant and surprisingly gentle. Light is not separate from the universe. It is part of the universe's ongoing activity, a vibration moving through a field that already fills all of space, a note played upon one of reality's oldest instruments. And yet, as important as the electromagnetic field is, it is only one voice among many, because the universe contains other fields as well, fields connected not merely to light, but to matter itself, fields whose stable vibrations help create atoms, fields whose patterns eventually become everything solid you have ever touched. And in a little while, we may begin to explore one of those fields and discover how the universe creates something that feels far more tangible than light itself. As we continue our slow journey through the hidden layers of reality, we arrive at a question that may have quietly followed us from the very beginning. If fields truly lie beneath everything, if light emerges from vibrations in one field, then what about matter? What about the things that feel solid? The chair beneath you, the pillow supporting your head, the walls around your room, the earth beneath your feet. How do these familiar things emerge from invisible fields? To begin answering that question, we must meet one of the most important fields in the universe, the electron field. You have likely heard of electrons before. Most people encounter the word in school. Tiny particles, tiny components of atoms, tiny building blocks of matter. But tonight, we will approach them a little differently. Not as tiny balls, not as microscopic planets, not as little objects orbiting through empty space. Instead, we will slowly explore a deeper possibility. The possibility that an electron is a stable vibration of the electron field. Imagine once again the image that has accompanied us throughout this journey, a vast invisible ocean stretching throughout space. When a ripple appears within that ocean, the ripple is not separate from the water. It is an activity of the water, a pattern within the water, a temporary expression of the water. Similarly, an electron can be understood as a pattern within the electron field. Not something separate from the field, but something emerging from it. A stable vibration, a persistent note within a much larger instrument. At first, this idea may feel strange. After all, electrons often appear in diagrams as tiny dots, tiny points, tiny particles. But those diagrams are simplifications, helpful sketches, not literal pictures. The deeper reality appears to be more subtle. Imagine listening to a single note played on a violin. The note feels distinct, recognizable, almost object-like. Yet the note is not a little object floating through the room. It is a stable vibration within a larger system, a pattern, an activity, something happening rather than something sitting. Electrons may be understood in a similar way, stable patterns within a field, and these patterns play an extraordinary role in the structure of atoms. For many years, people imagined atoms as miniature solar systems, a central nucleus surrounded by tiny electrons circling around it like planets around a star. It was a useful image, simple, easy to visualize. But nature turned out to be more interesting than that. The electron does not behave like a tiny planet. It does not travel around the nucleus along a neat little path. Instead, the electron field forms stable patterns around the nucleus, patterns that resemble standing waves. Imagine a guitar string once more. When plucked, the string does not vibrate randomly. It settles into preferred patterns, certain shapes, certain arrangements, stable modes that can persist. Now imagine replacing the string with the electron field surrounding an atomic nucleus. The field also settles into preferred patterns, stable arrangements, allowed configurations, places where the field naturally organizes itself. Rather than thinking of an electron as a tiny object racing around the nucleus, it can be helpful to imagine the field forming a stable standing pattern around it, a kind of resonance, a quiet balance, a pattern that nature allows. This picture helps explain one of the great mysteries of atoms. Why don't electrons simply fall into the nucleus? If electrons were tiny objects orbiting like planets, you might expect their motion to become unstable. Yet atoms remain remarkably durable. The atoms inside your body have existed for billions of years. Many of the atoms around you were formed long before Earth itself existed. The reason for this stability lies in the preferred patterns of the field. The field naturally settles into arrangements that can persist, stable forms, enduring structures, much like a musical note that resonates beautifully within an instrument. Imagine a cathedral once again. A soft note is sung. The architecture encourages certain resonances. The sound settles naturally into patterns, supported by the structure. The electron field behaves in a surprisingly similar way. Certain arrangements are favored, certain patterns endure, and from those patterns emerge atoms: hydrogen, carbon, oxygen, iron, the ingredients of stars, the ingredients of oceans, the ingredients of life itself, all built upon stable field behavior. Every star you see contains vast numbers of atoms, each atom containing patterns of the electron field. The light reaching your eyes has traveled enormous distances, and yet beneath that light lies a deeper story, a story of invisible fields settling into stable forms, again and again, across the universe, across billions of years. Across countless worlds, there is something quietly beautiful about this. The solidity of matter begins to feel less absolute, less rigid, more dynamic. The chair beneath you feels solid. The floor feels solid. Your body feels solid. Yet beneath that apparent solidity lies an intricate dance of fields, stable patterns maintaining their form, enduring arrangements persisting through time. Not frozen objects, but organized activity. The universe, it seems, is not built from static pieces. It is built from patterns that remain stable long enough for stars, planets, oceans, and living creatures to emerge. And yet the electron field alone cannot create all of matter. Atoms require something more. A dense center, a nucleus, a structure capable of anchoring those elegant electron patterns. To understand where that nucleus comes from, we must journey even deeper. Beneath atoms, beneath electrons, towards smaller field excitations, bound together by one of the most powerful influences in nature. And in a little while, we may begin to explore the fields that create protons and neutrons, and discover how the universe learned to build the foundations of matter itself. As our journey continues, we find ourselves moving deeper still. We have wandered through fields. We have followed waves through invisible landscapes. We have watched light emerge from vibrations in the electromagnetic field, and we have seen how the electron field settles into stable patterns that help form atoms. Yet one important question remains. If electrons form graceful patterns around the atom, what sits at the center? What creates the nucleus itself? What gives atoms their dense and stable heart? To answer that question, we must travel into an even smaller realm. Not because smaller things are necessarily more important, but because nature often builds complexity from layers of organization, patterns within patterns, structures within structures, like a melody composed of notes and notes composed of vibrations. Imagine standing beside an ancient stone cathedral. From a distance, the building appears solid and complete, a single structure, a unified whole. But as you move closer, you begin to notice details. Individual walls, individual stones, tiny features hidden within larger forms. And if you could somehow continue zooming inward, you would discover that even the stones themselves possess hidden structure. Reality behaves in a similar way. What appears solid from one perspective often reveals deeper layers when viewed more closely. For a long time, scientists believed protons and neutrons might be fundamental objects, tiny building blocks sitting at the centers of atoms, stable and indivisible. But eventually, evidence suggested something more subtle. Protons and neutrons appear to emerge from even deeper field activity, patterns built from smaller excitations, smaller vibrations, smaller notes within the larger symphony of nature. These excitations are known as quarks. The name itself is unusual, almost playful, and tonight there is no need to focus heavily on the terminology. The name is far less important than the idea. The important thing is that protons and neutrons are not simple objects. They are organized structures, stable arrangements emerging from underlying fields. Imagine a vast dance floor beneath soft evening lights. Across the floor, countless dancers move together. From a distance, you may notice larger formations appearing. Circles, lines, patterns, shapes that seem almost like individual entities. Yet when you look closely, the larger pattern is not separate from the dancers. It emerges from their collective movement. Protons and neutrons can be understood in a somewhat similar way, not as indivisible pieces, but as stable arrangements emerging from deeper field behavior. And here we encounter one of the most remarkable influences in the universe, a powerful binding influence often called the strong force. Yet even the word force can sometimes create the wrong image. It may suggest pushing, pulling, mechanical action, something abrupt, something dramatic. The deeper picture is gentler, fields responding to fields, patterns influencing patterns, relationships maintaining stability. Imagine stretching a piece of fabric between several points. The fabric naturally resists being pulled apart. The more you try to separate certain regions, the stronger the restoring influence becomes. The strong interaction behaves in a somewhat similar way. It creates an extraordinary tendency for certain field excitations to remain bound together, to stay connected, to form stable structures. Without this binding influence, protons would not exist, neutrons would not exist, atomic nuclei would not exist. The familiar matter around us would never have emerged. Imagine building a stone archway. Each individual stone contributes to the overall structure. Yet the arch survives because the stones support one another. Remove the organizing relationships, and the arch collapses. The strong interaction plays a similar role in nature. It helps maintain the integrity of deeper structures. It creates stability where instability might otherwise dominate. And this stability is astonishingly powerful. In fact, among the known interactions of nature, it is one of the strongest. Not across great cosmic distances, not stretching between galaxies, but within the tiny realm of atomic nuclei, within those hidden regions where matter finds its foundations. Imagine holding a grain of sand in your hand. It feels simple, ordinary, almost insignificant. Yet within that tiny grain exists an immense population of atoms. Within those atoms are nuclei. Within those nuclei are deeper field patterns, held together by this remarkable binding influence. A hidden architecture supporting the visible world. And perhaps there is something calming about that image. The realization that stability often emerges from relationship, not isolation, not separation, but connection. Patterns supporting patterns, structures maintaining structures. The universe appears filled with examples of this principle. Stars held together by gravity, atoms held together by electromagnetic relationships, and nuclei held together through this deeper binding influence. Layer upon layer of organization, layer upon layer of cooperation. As physicists explored these structures more deeply, they discovered that the story was not really about tiny objects at all. It was about fields. Once again, the same theme returns. The theme that has quietly accompanied us throughout this entire journey. Fields first, patterns second, objects emerging later. The deeper we look, the more reality resembles a tapestry of interacting fields rather than a collection of isolated pieces. And yet these fields do not exist independently. They continuously influence one another, respond to one another, shape one another's behavior. The universe is not a collection of separate conversations happening in isolation. It is a vast network of ongoing communication, an endless exchange of influence between fields, and in a little while, we may begin to explore how fields communicate with one another and discover how the interactions between fields give rise to what we experience as the forces of nature. As we continue our slow journey through the hidden architecture of reality, a remarkable picture has begun to emerge. What once appeared to be a universe built from tiny isolated objects now feels very different. We have encountered invisible fields stretching throughout space. We have watched those fields ripple and vibrate. We have seen stable patterns emerge as light, electrons, protons, and neutrons. Again and again, the same theme has returned. Fields first, particles second, patterns emerging from deeper structures. But now another question quietly appears. If the universe contains many different fields, how do they relate to one another? Do they exist independently? Do they ignore one another? Or do they somehow communicate? Imagine sitting quietly beside a lake at dawn. The water is still. A light mist hovers above the surface. The world feels peaceful and calm. Now imagine a gentle breeze drifting across the water. Almost immediately, the surface begins to respond. Small ripples appear. Patterns shift. The lake reacts to the movement of the air. Neither the breeze nor the water exists entirely alone. Each influences the other. Each responds. Something similar appears to happen throughout the universe. Fields do not simply occupy the same space without interaction. They influence one another, respond to one another, adjust to one another, and from these relationships emerge many of the phenomena we call forces. For centuries, forces seemed mysterious. Objects fell toward the earth. Magnets attracted or repelled one another. Electric charges influenced distant objects. These effects appeared almost magical, invisible influences reaching across space. Yet modern physics gradually revealed a deeper picture. Instead of imagining forces as mysterious actions occurring between isolated objects, we can imagine fields responding to fields, a continuous conversation, a network of influence, an ongoing exchange of information woven into the fabric of reality. Imagine a large field of tall grass beneath a gentle wind. As the breeze passes through, one region begins to move, then another, then another. A wave of motion spreads across the landscape. Each blade responds to its surroundings. The movement propagates naturally. No single blade acts alone. The pattern emerges through relationships. The universe often behaves in a similar way. A disturbance appears in one field, and nearby fields respond. Their responses influence other regions. Patterns spread, effects emerge. Reality unfolds through interaction. Imagine two musicians sitting together in a quiet room. One begins to play a note on a violin. Nearby, another instrument gently vibrates in sympathy. The second instrument was not directly touched, yet it responds to the sound filling the room. The vibration of one system influences another. This image captures something important about field interactions. Fields are not isolated islands. They participate in a shared environment. Changes in one field can influence patterns in another, and from these influences emerge the relationships we observe throughout nature. The electromagnetic field provides a familiar example. Earlier, we explored how vibrations within this field become light. But the electromagnetic field does more than carry light. It also interacts with charged particles such as electrons. Imagine sunlight streaming through a window. The light reaches a surface. Electrons within the material respond. Energy is transferred. Patterns change. The interaction becomes visible. The field carrying light influences the field associated with matter. A conversation takes place, not with words, not with thoughts, but with patterns, with responses, with exchanges of energy and information. This way of thinking can make the universe feel surprisingly alive. Not alive in the biological sense, not conscious, not intentional, but dynamic, responsive, connected. A vast web of relationships continuously unfolding. The strong interaction we explored earlier offers another example. The fields associated with quarks do not simply exist side by side. They remain connected through a powerful binding influence. Their relationship creates stability. Their interaction allows protons and neutrons to exist. Without that ongoing communication, atomic nuclei would never form. And there is yet another interaction operating throughout nature. A subtler one. An interaction involved in certain forms of transformation deep within atomic processes. Physicists call it the weak interaction. Tonight, there is no need to explore technical details. Only the broader idea matters. The universe contains multiple ways for fields to influence one another, multiple forms of communication, multiple kinds of relationship. Together, they help shape the behavior of matter and energy throughout the cosmos. Imagine an orchestra performing a slow piece of music. No instrument exists entirely alone. The violin responds to the cello responds to the flute responds to the rhythm beneath them all. Each contribution influences the larger whole, and yet no single instrument controls the entire performance. The beauty emerges through interaction. The universe appears to operate in a surprisingly similar manner. Many fields, many patterns, many forms of influence, working together to create the reality we experience. Even your own body depends upon these interactions. The atoms within your cells remain stable because fields interact. Light reaches your eyes because fields interact. The warmth of sunlight on your skin, the electrical activity within your nervous system, the chemistry that allows life to persist, all emerge from countless conversations occurring among fields. Most happen silently, most pass unnoticed, yet together they sustain the world you know. And perhaps the deeper lesson is a familiar one. Stability often emerges from relationship, not isolation, not separation, but connection. The universe is filled with examples of this principle: galaxies, stars, atoms, living systems. Again and again, complexity emerges when patterns interact, when structures communicate, when fields respond to one another. And as beautiful as this picture may be, it leads us toward another mystery. Because even when no particles appear to be present, even when space seems empty, even when all visible activity fades away, the fields remain, quietly present, quietly active, never completely still. And in a little while, we may begin to explore the surprising life of empty space and discover why the universe never truly falls silent. As we continue drifting through the hidden layers of reality, we arrive at an idea that may be one of the strangest and perhaps one of the most beautiful in all of modern physics. It begins with something that seems perfectly ordinary: empty space, the space between the stars, the space between planets, the space between atoms, the quiet gaps where nothing appears to exist. For most of human history, emptiness seemed simple. An empty room contains less than a full room. An empty glass contains less than a full glass. An empty road contains fewer travelers than a crowded one. And so it felt natural to imagine that truly empty space would contain absolutely nothing at all. No objects, no matter, no activity, no structure. Just emptiness, a perfect absence, a silent void. Yet as physicists explored the universe more deeply, they discovered that empty space is not quite what it seems. The deeper they looked, the more they found signs that space itself possesses a subtle kind of activity, a quiet background presence, a hidden restlessness, not dramatic, not violent, not chaotic, but never completely still. Imagine standing beside the ocean before sunrise. The water appears calm. The horizon fades softly into the darkness. At first glance, everything seems motionless. Yet if you watch carefully, you begin to notice tiny movements, small ripples, gentle swells, almost imperceptible shifts across the surface. The ocean is resting, but it is not frozen. Stillness and activity coexist. The quantum vacuum appears to behave in a somewhat similar way. The word vacuum simply refers to what physicists consider the lowest energy state of a field. In softer language, you might think of it as the field's quietest condition, its resting state, its calmest possible arrangement. Imagine a sleeping forest beneath moonlight. The animals have settled, the wind has softened, the day has ended. Everything feels peaceful. Yet the forest is not truly inactive. Leaves continue to move ever so slightly. Tiny creatures shift in hidden places. Branches creak softly. Life continues beneath the stillness. The vacuum resembles this kind of quiet activity. Even when a field rests in its calmest state, it does not become perfectly silent. Something remains. A subtle background motion, a gentle trembling beneath the surface. This idea surprised many physicists. After all, common sense often suggests that the lowest possible energy should mean complete stillness, no movement, no activity, no change. Yet the quantum world appears to refuse absolute silence. Instead, fields retain tiny fluctuations, tiny variations, tiny moments of activity, not because something is disturbing them from the outside, but because this gentle activity seems woven into their very nature. Imagine stretching a large sheet of fabric across a room. The fabric appears smooth and still. Yet if you look closely enough, you might notice tiny motions, small shifts, minute vibrations. The sheet never becomes perfectly motionless. There is always some subtle movement, some faint background rhythm. This image captures part of the feeling physicists describe when speaking about vacuum fluctuations. Not large waves, not dramatic disturbances, just tiny, ever-present variations within the fields themselves. And perhaps there is something comforting about this. The realization that complete emptiness may not exist, that even the quietest regions of the universe contain a gentle form of presence, a subtle texture, a hidden depth. Imagine floating through the vast darkness between galaxies. No stars nearby, no planets, no visible matter, only enormous stretches of space. For centuries, such a region might have been imagined as pure nothingness. But modern physics paints a different picture. Fields remain. The invisible landscapes we have explored throughout this journey continue to fill the region. The electromagnetic field remains. The electron field remains. Other fundamental fields remain. Even in apparent emptiness, the fields do not disappear. The stage itself remains present. And because the fields remain, a certain level of activity remains as well. The universe never becomes entirely silent, never entirely still, never entirely empty. At first, you think there is no sound at all, but as you listen more carefully, subtle details emerge. The distant hum of air moving through a vent, the soft ticking of a clock, the faint rustle of fabric, sounds so gentle that they almost disappear into the background. The vacuum is somewhat like that, a state of extraordinary quietness, yet not absolute silence, a calm background hum beneath reality, a subtle activity woven into the fabric of existence. This idea eventually led physicists to a deeper realization. Fields are not occasional visitors to space. They are part of space itself, not objects floating inside a container, not decorations placed upon an empty stage. They are woven into the very structure of reality. And because fields remain everywhere, their quiet activity remains everywhere as well. The universe begins to feel less like an empty box containing objects and more like a continuous landscape, a landscape that never entirely sleeps, a landscape that never entirely falls silent, a landscape where even apparent emptiness possesses texture and character. And among all the fields filling this landscape, one stands out in a particularly remarkable way. A field that extends throughout the cosmos, a field whose presence influences many of the particles we have already encountered, a field that helps explain why some patterns of matter possess mass, while others do not. A field so pervasive that, in a sense, you are immersed within it right now. And in a little while, we may begin to explore that remarkable field and discover how it quietly helps give weight to the world around us. As we continue drifting through the hidden landscape of fields, there is one question that has been quietly waiting for us. A question that may not seem obvious at first, because by now, the universe already contains so much. Fields stretch throughout space. Waves ripple through those fields. Light travels across vast distances. Electrons form stable patterns. Protons and neutrons emerge from deeper structures. Atoms become possible. And yet something important remains unexplained. Why do some patterns of matter feel heavy while others do not? Why does a stone resist being pushed more than a drifting beam of light? Why does matter possess weight? Why does it possess resistance to change? Imagine standing beside a calm river. You place a small leaf upon the surface. The leaf responds immediately to the current. It drifts effortlessly, almost weightlessly. Now imagine placing a large wooden log into the same river. The current still affects it, but the response is different, slower, more gradual. The larger object does not change its motion as easily. It possesses a kind of stubbornness, a reluctance to change. Physicists use the word mass to describe this property, but tonight, you can simply think of it as resistance to change. The tendency of a pattern to continue behaving the way it already is. And this brings us to one of the most remarkable fields in the universe, the Higgs field. Unlike many of the fields we have discussed, the Higgs field is unusual because it appears to fill all of space, not just certain regions, not just around stars or planets, but everywhere. A quiet background presence woven throughout the cosmos. Imagine walking through a gentle morning mist. The mist surrounds you completely. You move through it without necessarily paying attention to it. It fills the landscape. It becomes part of the environment itself. The Higgs field can be imagined in a somewhat similar way, not as a cloud, not as a substance, but as a field that quietly exists throughout the universe. And the fascinating part is this: different particles interact with this field in different ways. Some interact very strongly, others interact only weakly, and these differences help determine how much resistance to change those particles possess. Imagine walking through shallow water near a beach. Your movement feels easy. The water offers only a gentle resistance. Now imagine walking through deeper water. Each step requires a little more effort. The environment influences how easily you move. This is not a perfect comparison, but it captures part of the intuition. The Higgs field quietly influences how particles respond to motion and change. Some particles interact with it more strongly, some interact with it less, and as a result, they exhibit different amounts of mass, different amounts of resistance, different degrees of inertia, or, in the softer language of our journey, different levels of reluctance to change. Imagine an orchestra once again. A familiar image by now. Some instruments produce light, delicate sounds. Others produce deep, resonant tones. The instruments share the same concert hall, yet each interacts with the space differently. Each produces its own character, its own presence. Particles behave in a somewhat similar way. They exist within the same universe. They move through the same Higgs field. Yet their interactions differ, and from those differences emerge many of the properties that make the physical world possible. Without the Higgs field, the universe would look very different. The stable structures we have been exploring might never have formed. Atoms would struggle to exist in their familiar form. Stars might never ignite. Planets might never emerge. The intricate architecture of matter would be profoundly altered. It is a quiet field, an invisible field, yet its influence reaches astonishingly far. Imagine a vast city at night. From above, countless lights glow softly in the darkness. Roads connect neighborhoods. Buildings stand in careful arrangement. Everything appears stable, orderly, structured. Yet much of that stability depends on systems hidden from view. Foundations beneath the streets, frameworks within the buildings, invisible supports quietly doing their work. The Higgs field is somewhat like one of those hidden supports, rarely noticed, almost never seen directly, yet deeply important to the structure of the world. And perhaps there is something comforting about that idea. Some of the most important influences in reality are not the loudest, not the brightest, not the most obvious. They work quietly, patiently, continuously, beneath the surface. The Higgs field is one of those influences, a field that quietly helps shape the properties of matter, a field that contributes to the remarkable diversity of particles within the universe, a field that helps transform a simple collection of vibrations into a cosmos capable of structure and stability. And now, after our long journey through fields, waves, interactions, and hidden patterns, something important is finally beginning to come together. The ingredients for matter are almost complete. The fields are present. The stable vibrations are present. The interactions are present. The resistance to change is present. The foundations have been laid. All that remains is to see how these ingredients combine, how fields organize themselves into atoms, how atoms gather into molecules, how molecules build the materials that surround you every day: water, air, wood, stone, and eventually, life itself. And in a little while, we may begin to watch matter emerge from these invisible fields and discover how the ordinary world grows from extraordinary foundations. As we continue our slow journey through the hidden foundations of reality, something remarkable is beginning to happen. For a long time, we have been gathering ingredients, invisible fields, gentle vibrations, stable patterns, interactions between fields, the quiet influence of the Higgs field. One by one, the pieces have slowly come together. And now, at last, we can begin to see how the familiar world emerges. The world of water and stone, the world of trees and clouds, the world of oceans, mountains, and living creatures. The world you experience every day. Imagine standing at the edge of a beach just before sunrise. The sky is beginning to brighten. The waves move softly across the sand. Everything feels calm, simple, peaceful. Yet beneath that apparent simplicity lies an astonishing amount of hidden organization. Every grain of sand, every drop of water, every breath of air, built from countless atoms, and every atom emerging from the field patterns we have explored together. Let us begin with the atom itself. Imagine an atom not as a tiny solar system, but as a stable arrangement of fields. At its center rests a nucleus. Around it exist the standing patterns of the electron field. Everything balanced, everything organized, a quiet harmony. Not frozen, not static, but stable. Like a musical chord that can linger beautifully in the air. A single atom is already an extraordinary achievement of nature. Yet the universe rarely stops with single atoms. Atoms meet other atoms. They interact. They respond to one another. And from these encounters, something new emerges. Molecules. Imagine individual notes floating through a concert hall. Each note is complete on its own. Yet when several notes combine, a melody appears. A richer pattern. A larger structure. Molecules are somewhat similar. Individual atoms join together to create new arrangements, new possibilities, new forms of stability. The universe seems to enjoy building larger patterns from smaller ones, again and again, across every scale. Imagine two people standing quietly beside a campfire on a cool evening. Gradually others arrive. Small groups form. Conversations emerge. Relationships develop. The gathering becomes something more than the sum of its parts. Atoms behave in a surprisingly similar way. Certain arrangements feel natural. Certain combinations remain stable. Certain partnerships endure. And from these partnerships emerge the molecules that fill our world. Water molecules, oxygen molecules, carbon-containing molecules, countless arrangements woven throughout nature, each one a pattern, each one a form of organized field behavior. Imagine holding a glass of water. The water feels simple, ordinary, familiar, yet hidden within that glass are vast numbers of molecules, each molecule built from atoms, each atom emerging from fields. The simplicity you experience on the surface conceals an extraordinary depth beneath. The same is true of air. You breathe without thinking about it. Inhale, exhale, a calm rhythm accompanying your life from beginning to end. Yet the air around you contains countless molecules moving through space, invisible patterns, organized structures, a quiet dance unfolding continuously around you. Now imagine a piece of wood, perhaps an old tree standing quietly in a forest. Its trunk feels solid, reliable, strong, but beneath that solidity lies an intricate architecture of molecules, arranged in stable patterns. Those molecules emerge from atoms. Those atoms emerge from fields. The tree itself becomes another expression of organized field behavior, and the same story continues with stone, a mountain, a riverbank, a pebble resting beside a path. Each appears solid and permanent, yet beneath every surface lies an invisible world of patterns, interacting and organizing themselves. Again and again, the same theme returns. Fields becoming vibrations, vibrations becoming particles, particles becoming atoms, atoms becoming molecules, molecules becoming matter. The universe building complexity through layers of organization. Imagine a vast cathedral under construction. One stone is placed, then another, then another. Gradually arches appear, walls emerge, windows take shape. Eventually a magnificent structure stands. Where once there was only empty ground, matter emerges in a somewhat similar way. Small patterns combine into larger patterns. Simple arrangements become complex arrangements, and complexity slowly blossoms throughout the universe. Perhaps one of the most beautiful aspects of chemistry is that it demonstrates how much variety can emerge from relatively simple ingredients. The same fundamental fields exist throughout the cosmos. The same underlying rules operate everywhere, yet from those foundations emerge oceans and deserts, clouds and forests, crystals and coral reefs, snowflakes and stars, an astonishing diversity of forms. Imagine a composer creating an entire symphony using only a limited number of musical notes. The notes themselves remain the same, yet endless combinations become possible. Endless melodies, endless harmonies. Nature appears to possess a similar creativity. The fields remain the same, the underlying principles remain the same. Yet the resulting structures become wonderfully diverse. And as complexity continues to grow, something even more extraordinary eventually becomes possible. Patterns begin organizing themselves in new ways. Molecules form larger systems. Larger systems become capable of maintaining themselves, adapting, persisting, growing. The boundary between chemistry and life begins to soften. The story of atoms gradually becomes the story of living things. The same fields that shape stars also shape cells. The same patterns that organize matter eventually help organize life. And in a little while, we may begin to explore how living systems emerge from these extraordinary arrangements and discover how life itself can be understood as a beautiful pattern within the universe of fields. We arrive at something wonderfully familiar, something very close. Closer than the stars, closer than the oceans, closer even than the air around you. We arrive at life, your life, the life of every tree, every bird, every flower, every creature that has ever wandered beneath the sky. And perhaps, after everything we have explored together, a quiet question begins to emerge. If fields give rise to particles, and particles give rise to atoms, and atoms give rise to molecules, then what gives rise to life? What transforms simple matter into something that grows, adapts, heals, and persists? Imagine standing beside a river at sunset. The water moves steadily downstream, not quickly, not slowly, just continuously. If you return tomorrow, the river will still be there. If you return next year, it will still be there. And yet the water itself will be different. The water you see today will have long since flowed away. New water will have taken its place. The river remains. The contents change. Life often behaves in a surprisingly similar way. Your body feels stable, continuous, familiar. You recognize yourself in the mirror. You remember your childhood. You carry memories, habits, preferences, and experiences. You feel like the same person you were yesterday. And yet, beneath that feeling of continuity, change is happening all the time. Cells are replaced. Molecules come and go. Atoms enter and leave your body through food, water, and air. The physical ingredients are constantly changing. And still, somehow, you remain yourself. This is one of the most fascinating aspects of life. Identity appears to be less like a permanent object and more like a pattern, a stable arrangement, a flowing process. like a river maintaining its shape while its contents continue moving. Imagine a candle burning quietly in a dark room. The flame appears steady, stable, continuous. Yet the flame is not a fixed object. Fresh fuel enters, heat escapes, air flows around it. The flame persists because a pattern persists, not because the exact same material remains in place. Life behaves in much the same way. The pattern continues, the components change, the organization remains. And what are those components ultimately made of? Atoms, molecules, fields, the same ingredients we have been exploring throughout our journey. There is no special substance reserved exclusively for living things, no separate set of fundamental fields hidden inside biology. The atoms within a leaf are built from the same underlying fields as the atoms within a mountain. The atoms within your body arise from the same fundamental reality as the atoms within distant stars. The universe does not switch rulebooks when life appears. The same fields continue. The same patterns continue. Only the organization becomes more intricate, more layered, more extraordinary. Imagine a vast orchestra once again, a familiar companion on our journey. A single violin note is beautiful. A small melody is beautiful. But when hundreds of instruments work together in careful coordination, something new emerges. A symphony. Not because new notes have been invented, but because existing notes have become organized in increasingly complex ways. Life appears to emerge through a similar process. The fundamental ingredients remain the same. The organization becomes richer. The patterns become more elaborate. The relationships become more interconnected. And eventually, living systems appear. Imagine looking at a forest from high above. At first glance, it may seem like a collection of separate trees. Yet beneath the surface lies an intricate network. Roots exchange nutrients. Water cycles through the environment. Microorganisms transform matter. Sunlight powers growth. Countless processes interact simultaneously. The forest becomes more than a collection of individual parts. It becomes a living system. Your body is similar. Trillions of cells, countless molecules, continuous exchanges of energy and information. Patterns interacting with patterns. Structures supporting structures. All working together to maintain a remarkable state of dynamic stability. Not frozen, not static, but continuously active, continuously adapting, continuously alive. Imagine a city at night. Lights glow in windows. Vehicles move along roads. People carry out countless activities. The city remains recognizable, even though its activity never stops. Life possesses a similar quality. Order emerging through motion, stability emerging through change, continuity emerging through constant renewal. And perhaps there is something deeply reassuring about this perspective, because it reminds us that change is not necessarily the opposite of stability. Sometimes change is what allows stability to exist. The river flows and remains a river. The flame flickers and remains a flame. The living body changes and remains alive. Again and again, the universe demonstrates that patterns can endure even while their components continue moving. And perhaps that is one of the quiet lessons hidden within the story of fields. Reality is not built from rigid, unchanging objects. It is built from relationships, processes, patterns, structures that maintain themselves through time. Life becomes one of the most beautiful examples of this principle, a temporary yet enduring arrangement within a much larger universe, a delicate pattern woven from the same fields that fill space itself. And as extraordinary as life may seem, the story of fields stretches even farther, beyond forests, beyond oceans, beyond living creatures, back toward the earliest moments of the universe itself, toward a time before stars existed, before planets existed, before atoms existed, a time when the fields we have been exploring were young, energetic, and still settling into the forms we know today. And in a little while, we may begin to drift back toward the beginning, and discover how the early universe gradually transformed into the cosmos that now surrounds us. As we continue our slow and gentle journey, we now find ourselves drifting backward beyond cities, beyond forests, beyond oceans, beyond Earth itself, past the stars, past the galaxies, past everything that feels familiar. We are traveling toward a time before planets existed, before atoms existed, before light could move freely across space, a time when the universe was unimaginably young. And yet, even here, the story remains the same, the story of fields, because throughout our journey, one idea has quietly followed us everywhere. Fields first, everything else later, and nowhere is that idea more important than in the earliest moments of the cosmos. Imagine arriving beside a lake shortly after a powerful storm has passed. The wind is fading, the clouds are beginning to part, but the water is still restless. Large waves roll across the surface. Ripples overlap one another. The lake has not yet returned to calmness. It is still carrying the memory of its earlier energy. The early universe can be imagined in a somewhat similar way, not as an explosion, not as debris rushing through empty space, but as an extraordinarily energetic state, a cosmos filled with highly excited fields, a universe overflowing with activity. Imagine a great orchestra, moments before a performance begins. Every musician is playing. Notes overlap. Sounds fill the hall. There is energy everywhere. Movement everywhere. Potential everywhere. Nothing has settled yet. Nothing has organized itself into the beautiful structure that will later emerge. The earliest universe may have possessed a similar feeling. Fields vibrating intensely. Interactions occurring constantly. Patterns forming and dissolving with incredible speed. And yet, as time passed, something remarkable began to happen. The universe started to cool. Not suddenly, not dramatically, but gradually, patiently. The way a cup of tea slowly cools on a quiet evening. The way warm sand releases heat after sunset. The way a stormy sea eventually returns to calm water. The universe began settling, and as it settled, the fields themselves began finding more stable arrangements. Imagine once again that lake after the storm. The largest waves begin to fade. Smaller ripples remain. Then even those become gentler. Eventually, the surface becomes smooth enough to reflect the sky. Order emerges from motion. Structure emerges from activity. The young universe appears to have followed a similar path. As temperatures decreased, the fields no longer possessed enough energy to remain in their most excited states. They began settling into more stable patterns. And from those patterns emerged many of the particles we have discussed throughout our journey. Electrons, quarks, photons, the familiar excitations of the fundamental fields, not appearing all at once, not appearing by magic, but gradually emerging as the universe cooled and organized itself. At first, the air contains only invisible water vapor. Nothing remarkable appears to be happening. Then conditions change. The temperature falls. Patterns become possible that were impossible before. Tiny crystals begin to emerge. Order appears naturally. The formation of matter in the early universe can be imagined in a somewhat similar way. As conditions changed, new forms of organization became possible. Fields that had once been extraordinarily energetic settled into patterns stable enough to persist. The universe began constructing its foundations. First came the smaller building blocks, then larger structures emerged. Protons and neutrons formed. Eventually, atomic nuclei appeared. The ingredients for future atoms slowly assembled themselves, yet the universe was still very different from the one we know today. Imagine a world covered entirely by fog. The landscape exists, the mountains exist, the rivers exist, but visibility remains limited. Everything is hidden behind a veil. For a long time, the early universe was somewhat similar. Light existed, but it could not travel freely across vast distances. The environment remained too crowded, too dense, too active. The light continually interacted with surrounding matter. Only later, as expansion continued and cooling progressed, did space become transparent enough for light to travel freely. The universe gradually became visible. The cosmic fog lifted, and light began a journey that continues even now. Some of that ancient light still travels through the cosmos today, a faint echo from the early universe, a quiet reminder of those distant beginnings. Imagine walking through an old forest and discovering rings inside the trunk of a fallen tree. Those rings preserve traces of the past. They tell a story about earlier seasons, earlier years, earlier conditions. The universe also carries memories of its past, not through tree rings, but through subtle patterns still visible throughout space. Clues that help us reconstruct its history. Clues that reveal how fields gradually organized themselves into the structures we observe today. And from those structures emerged something extraordinary. Stars, great furnaces of light, places where atoms gathered together under gravity, places where heavier elements formed, places that would eventually provide the ingredients for planets, oceans, mountains, and life. Imagine countless sparks appearing across a dark landscape, small points of light gradually illuminating the night. The first stars brought light to a universe that had once been far simpler. Galaxies began to emerge. Vast collections of stars gathered together. Structures formed on increasingly larger scales. Yet beneath all this complexity, the same theme remained. Fields, patterns, organization, the universe becoming more elaborate, while still following the same underlying principles. And perhaps there is something deeply comforting about that continuity. The same fields present in the early universe remain present now. The same foundations that shaped the first atoms continue shaping reality today. The same invisible structures that filled the cosmos billions of years ago still surround you at this very moment. The story has become more complex, but the underlying patterns remain. And hidden beneath this long evolution lies an even deeper principle. A principle that helps explain why the universe remains orderly, why the laws of nature remain reliable, why the same patterns appear again and again across space and time. And in a little while, we may begin to explore that principle and discover why the universe As we continue drifting through the story of fields, patterns, and the unfolding universe, we arrive at a quiet mystery that hides in plain sight. A mystery so familiar that it is easy to overlook. Why does reality remain so reliable? Why does the universe behave consistently enough for stars to shine, planets to orbit, oceans to move with the tides, and life to emerge from matter? Why do the same patterns appear again and again? Imagine waking before sunrise and walking to a nearby shoreline. The sky slowly brightens. Waves roll gently toward the sand. The rhythm feels familiar. Tomorrow the waves will return. Next week, they will return. Years from now, they will still arrive. Not in exactly the same way. Not as identical waves, but according to patterns that remain remarkably dependable. There is comfort in that consistency. A quiet reliability woven into the world. And the deeper physicists explored reality, the more they discovered that this consistency extends far beyond beaches and oceans. It reaches into the smallest particles, the largest galaxies, the deepest layers of space and time. Again and again, nature reveals an extraordinary preference for order. Not rigid order, not perfect repetition, but dependable structure, patterns that persist, relationships that remain stable. Imagine listening to a favorite piece of music. Each time the melody plays, individual notes may sound slightly different. The room may be different. Your mood may be different. The performance may change in subtle ways. Yet the melody remains recognizable. Something essential persists beneath the variation. The universe behaves in a surprisingly similar manner. Conditions change. Objects move. Stars are born and eventually fade. Yet underlying patterns remain. The deeper structure endures, and one reason for this stability lies in an idea that physicists call symmetry. Tonight, however, there is no need to focus on technical definitions. Instead, imagine symmetry as a kind of consistency, a reliability woven into reality itself. Imagine standing in a forest. You take a few steps forward. The laws of nature do not suddenly change. Gravity continues to work. Light continues to travel. Matter continues to behave as matter. Now imagine traveling far across the earth, across oceans, across continents. Again, the same principles remain. The universe does not rewrite its rules every few miles. The same underlying patterns appear again and again. This remarkable consistency allows science to exist at all. Because if reality behaved completely differently from one place to another, understanding would become nearly impossible. Yet nature appears surprisingly coherent. A star on the far side of the galaxy follows many of the same principles as a star much closer to home. The same fields operate, the same interactions occur, the same foundations remain. Imagine a vast tapestry stretching beyond the horizon. The details vary from place to place, different colors, different shapes, different textures, yet the same threads run throughout the entire fabric. The universe appears to possess a similar unity, diversity on the surface, consistency underneath. And from this consistency emerge many of the stable patterns we rely upon. Imagine placing a ball on a gentle hillside. You release it. It rolls downward. Tomorrow, it will do the same. A year from now, it will do the same. Not because the universe is repetitive in a mechanical sense, but because the underlying relationships remain dependable. Nature remembers its own patterns, again and again. The same causes lead to similar effects. The same structures produce similar outcomes. The same fields respond in familiar ways. And this consistency carries an important consequence. Certain quantities remain balanced through change. Certain patterns persist, even as events unfold. Imagine a river flowing through a valley. The water constantly moves. Individual droplets come and go. The landscape changes slowly over time. Yet the river maintains a recognizable identity. A deeper pattern survives the motion. Nature contains many examples of this principle. Change occurring within stability, motion occurring within order, transformation occurring without chaos. This balance allows stars to burn steadily for millions and billions of years. It allows atoms to remain stable. It allows chemistry to function. It allows life to emerge. Without consistency, complexity would struggle to survive. Imagine building a house on shifting sand that changed shape every few moments. The structure would never remain standing for long. But the universe provides a reliable foundation, a framework stable enough for complexity to grow, stable enough for galaxies, stable enough for planets, stable enough for life. Perhaps this is one of the quiet miracles of existence. Not that reality is complicated, but that reality is understandable, not perfectly understandable, not completely solved, but understandable enough that patterns can be discovered, understandable enough that curiosity can lead somewhere. Imagine walking beneath a night sky filled with stars. At first, the stars seem scattered randomly across the darkness. Yet over time, people learn to recognize constellations, patterns, relationships, regularities. The sky revealed an underlying order hidden within apparent complexity. The history of science often follows a similar path. Looking beyond surface appearances, discovering deeper patterns, finding unexpected unity beneath diversity, and nowhere is that more evident than in the story we have explored together. Light and matter, particles and waves, atoms and galaxies, all connected through fields, all participating in the same underlying framework. The universe appears vast beyond imagination. Yet beneath that vastness lies an elegant coherence, a quiet consistency that allows reality to remain recognizable, from one moment to the next. And yet, for all that we have learned, important mysteries remain. Questions still waiting in the darkness. Questions about gravity. Questions about dark matter. Questions about dark energy. Questions about how all the fields ultimately fit together. The deeper we look, the more we discover, and the more we discover, the more mystery remains. But perhaps that is part of the beauty. The universe is understandable enough to explore, and mysterious enough to inspire wonder. And in a little while, we may gather everything we have learned together, from fields and particles to stars and life, and listen once more to the great symphony of reality. And so, as our journey begins to drift toward its quiet conclusion, you may notice how different the universe feels now compared to when we first began. At the beginning, we asked a simple question: what is reality made of? A question that seemed straightforward, a question that appeared to invite a straightforward answer. Perhaps tiny particles, perhaps tiny building blocks, perhaps little objects hidden beneath larger ones. But as we wandered deeper, the picture slowly changed. The particles became vibrations. The vibrations became patterns. The patterns became expressions of fields. And gradually, the universe transformed from a collection of objects into something more fluid, more connected, more subtle, a vast symphony of invisible fields filling space itself. Before we rest, let us gather the threads of that story one final time. Not quickly, not as a review, but as a gentle walk through a familiar landscape. Imagine sitting quietly in your room late at night. The lights are dim. The world has become still. Perhaps the only sound is the soft rhythm of your breathing. Everything feels ordinary, comfortable, familiar. Yet even here, surrounded by everyday objects, the hidden world of fields remains active. The screen that glows softly in a dark room, the signal traveling invisibly to a phone, the light from a lamp, the warmth from sunlight remembered through a window. All are connected to fields. The electromagnetic field carrying vibrations across space, patterns moving through an invisible structure that fills the universe. Technology often feels modern, complex, separate from nature. Yet beneath the surface, it depends upon the same fields that illuminate the stars, the same fields that existed long before human beings appeared. Imagine a message traveling across the world, crossing oceans, crossing mountains, crossing cities, sleeping beneath the night sky. To us, the journey feels effortless. Yet beneath that simplicity lies an intricate dance of field interactions, invisible patterns moving through reality. Again and again, the modern world quietly reminds us that fields are not abstract ideas. They are woven into everyday experience. The same is true of medical imaging, navigation systems, wireless communication. Countless devices surrounding modern life, not because engineers directly manipulate reality itself, but because they have learned to work with patterns already present within the fields of nature. The hidden architecture of the universe quietly participates in daily life, and yet, despite everything we have learned, mysteries remain. Imagine standing at the edge of a vast forest at twilight. You have explored many paths. You have discovered clearings, streams, and hidden valleys. You understand the landscape far better than when you first arrived. Yet beyond the next ridge, the forest continues. New paths remain unseen. New questions remain unanswered. Physics finds itself in a similar position today. Much has been discovered. Much has been understood. Yet some of the deepest questions remain open. Gravity, for example. The influence that guides planets around stars. The influence that shapes galaxies. The influence that helps sculpt the large-scale structure of the cosmos. Scientists understand many aspects of gravity remarkably well, yet they continue searching for a deeper understanding of how gravity fits into the broader story of quantum fields. The journey is not finished. Another mystery appears in the form of dark matter, a name given to something that reveals itself through its influence. Galaxies seem to contain more than we can directly observe, something hidden appears to contribute to their structure, something present, yet not fully understood. And beyond that lies dark energy, a phrase used to describe another profound mystery. The universe appears to be expanding in a way that surprises us. Something influences that expansion. Something remains unexplained. Perhaps future generations will understand these mysteries more clearly. Perhaps entirely new discoveries await. Perhaps the story of fields is still only beginning. And there is something comforting about that thought. The universe remains mysterious, not because understanding has failed, but because curiosity continues. Because there is always another horizon, always another question, always another quiet invitation to explore. Imagine once again the journey we have taken. Fields filling space, ripples moving through those fields, light emerging from vibrations, electrons forming stable patterns, protons and neutrons arising from deeper structures, atoms gathering into molecules, molecules organizing into matter, matter becoming stars, planets, oceans, forests, living creatures. Again and again, the same theme returns. Patterns within fields, structure emerging from relationship, complexity arising from simple foundations. The universe begins to resemble an enormous piece of music, not a melody composed by a person, not a song performed for an audience, but a natural harmony unfolding across space and time. Each field contributes its own voice. Each vibration contributes its own note. Each interaction contributes its own subtle rhythm. And together, they create the reality we experience. A symphony of fields, a symphony still unfolding. Even now, as you rest, as you listen, as you drift closer to sleep, and perhaps, before we say goodnight, it is worth returning to one final image. A quiet room, a calm breath, the soft darkness of evening. You are resting within a universe filled with invisible fields, the same fields that stretch through distant galaxies, the same fields that carry starlight across the cosmos, the same fields that help shape atoms, oceans, forests, and living things. They are present everywhere, quietly, patiently, continuously. You are not separate from the universe observing it. You are one of its countless patterns, a brief and beautiful arrangement of the same fields that fill the stars, the sky, and the silent spaces between them. And so, our journey drifts quietly to its end. Whether you're still listening beneath the glow of your screen or already floating somewhere between dreams and distant stars, thank you for traveling here tonight. Through silent galaxies, ancient particles, and the quiet laws that hold the universe together. If this wandering brought you a little calm, you're welcome to subscribe or share it with someone who could use a gentler night beneath the cosmos. For now, rest well. The stars will keep burning, the planets will keep turning, and the universe will carry on softly around you while you sleep